Hello everyone. Today's topic is real numbers and their decimal expansion. This topic is based on class 9 number system. In the previous lecture, I have explained that all the rational numbers are real numbers and can be expressed in the form of decimal. So let's start. Here a quick revision of rational numbers. Any number which is a form of p by q, where p and q are integers and q is not equal to 0 are called rational number denoted by capital Q. Okay, in this video we will learn how to change rational number to decimal form and decimal to rational form. Let's start. In the junior classes you all have learned that a rational number 1 by 2 can be simply turned into decimal by dividing 1 by 2. 1 is less than 2, so we put point and increase 0. 2 5s are 10. We will get remainder 0. So 1 by 2 is equal to 0.5, where remainder is 0. So these kind of numbers in which after decimal digit terminates, means digit ends, called terminating rational number. Terminating decimal expansion. Simply we can get 7 by 8. Another example. Take another example. 7 by 8 means we will divide 7 by 8. So 7 is less than 8. So we will put point and increase 0. 8 8s are 64. Remainder is 6. Here's point. So we will increase 0. 8 7s are 56. I hope you all know the division very well. 4 is remainder. 8 5s are 40. So we will get remainder 0 here. So 7 by 8 is equal to 0.875. This decimal expansion is also a terminating decimal expansion where remainder is 0. Another form is the remainder which is not 0. Just take an example, 10 by 3. When we will divide 10 by 3, simply 3 3s are 9, minus, we'll get remainder 1. Now put decimal, increase 0. 3 3s are 9. Again we will get remainder 1. Here decimal, so we will increase 0. 3 3s are 9. Again we will get remainder 1. So this term 0.33333 will never end. We will get always remainder 1. Here remainder is not 0. So these kind of decimal expressions are called non-terminating and recurring because 3 is repeating. So non-terminating recurring are rational numbers. Here one more example, 1 by 7 is equal to 0.142857. Again 142857. Again we will get 124857 and so on. This term will not terminate. So this is also a non-recurring and non-terminating and recurring rational number. One more thing, we can write 3.33 in shorter way, 3.3 bar, which means 3 is repeating digit. Similarly, we can write 0.14287 by bar like this. This means 14287 this pattern is repeating. I hope you all understood this both kind of decimal expansion. Moving to the next. Now we have a decimal expression and we have to change. Now we have a decimal expansion and we have to change this in a rational form. So simply, if we have 3.15, so what we will do, we can write this like 3.15 upon 1, and here after decimal 2 digits, so we will multiply this by 100. If 1 digit, then we will multiply this by 10. Then what we will get? By multiplying 3.15 into 100, we will get 315 and upon 100. So this is the rational representation of 3.15. Take another example. Like we have 1.5. So how we will represent it in decimal rational form? 1.5 upon 1 into 10 upon 10. So 15 by 10. So we will divide this by 5. So we will get 3 by 2. So 3 by 2 will be the rational representation of 1.5. Hope you all have understood properly. Moving to the next. Now we have a problem. We have this 0.3333 means non-terminating and recurring rational number. Now there is a question how we will represent this in a rational form. I have two methods for this. Both I will tell you one by one. First by using a step-by-step method and second would be the formula. Okay, so let's start solving this solution. Let x is equal to 0.333. This is our equation number 1. Since it has a 1 digit repeating after decimal, so we will multiply this equation by 10 and we will get 10x is equal to 3.333 and so on. So in what we can write this? 3 plus 0.333 and we have let this is x. So what we will get? 3 plus x. So we will get 10x is equal to 3 plus x. Okay. And when we take x to the left side, 10x minus x is equal to 3. So 9x is equal to 3. So we will solve this here. 9x is equal to 3. So x is equal to 3 by 9 and is equal to 1 by 3. So here rational representation of 0.33333 decimal expansions. Hope you have understood this very clearly. Here only one digit is repeating. After decimal, all digit is repeating. There is not any non-repeating digit. Okay, this is the most important point you have to understand. All digits after decimal is repeating. Now we will solve similar question by this formula. This you can use in objective questions. That method you will use in subjective questions and this formula will you use in objective questions. Okay, so let's take similar example. Means we have 0.3333. We can write this 0.3 bar. So we have to change this in a p by q form. So we have formula. In a decimal number, this is a decimal number. If after decimal point all digits repeat, Here only 3 which is repeating, means there is no non-repeating digit. There is 3 which is repeating digit. So what we will do, in the numerator we will write the recurring digit only once. We will write recurring, here only 3 is repeating, so we will write 3 here, and in the denominator write as many 9s as the number of repeating digit. So here only one digit is repeating, so we will write only 1 9, and after adding this we will get 1 by 3. So simply we have used this formula and got this answer. We can see in the previously we have also got this answer 1 by 3, and similarly by using this formula we have got this answer. Now we have some other type of question. Now we have another type of problem. Here point here 0.23535 means 2 is non-repeating and 3535 is repeating. So again we will solve this by two methods. One is by step-by-step process and another is by formula. So first let x is equal to 0.23535, so on. This is our equation number 1. Since we have after decimal 2 digits are repeating here, so we will multiply this by 100. 100 x is equal to 100 into multiply this digit. What we will get? 23.53535. Now how we can write this? We can write this 23.3 plus 0.23535, so on. And we have assumed this x from equation number 1. So what we will get? 100x is equal to 23.3 plus x. Okay. Now we will solve this here. So from taking x to the left side, we will get this 99x is equal to 23.3. So x is equal to 23.3 by 99, and when we will remove this point, we will put 0 in the denominator. So what would be the answer? 233 by 0. This will be the decimal representation. This will be the rational representation of decimal number. I hope you have understood properly. Now moving to the formula. Here we have a formula also. If after decimal some digits repeat, means not all digits are repeating. We will take same example where 2 is not repeating and 5 is repeating. So we will write this in the form of P by Q. First we will write complete number, means 235, minus, we will put minus number found by non-repeating digit. Non-repeating digit is here 2. In the denominator we will write as many 9 as the number of repeating digit, means repeating digit here only 2, so we will write 2 times 9 here, and after that write 0 as many number of non-repeated digit. So we have only one non-repeating digit, so we will put 1 0 here. Now we will solve this. 233990. So this will be the answer. You can check. same answer we have got by solving and by this process, 233 by 990, and by using this formula we have also got this same answer. Now you will solve these two by yourself. Moving to the next, we have some more examples. First, pause the video and solve by yourself by using the method and also the formula. Then look my answers. Okay, so question number 1, 0.47 bar. So we will use here formula number 2, where not all digits are repeating. 4 is not repeating and 7 is repeating. So first we have to write the complete number. After that we will write non-repeating digit, which is 4. Then we will write 9 as number of repeating digits, non-repeating digits. So we have 7 with only one non-repeating digits, and then we will put 0 as a number of non-repeating digits. So we have 4 as a non-repeating digit. Then what we will get the answer? 43 by 90. This is the rational representation of decimal expansion. Question number 2, 0.001. Here we can see all the digits are repeating. So we will use formula number 1. We can see all the digits after decimal is repeating. So we will write repeating digits on upper side, numerator, and number of nines as many as number of digits repeating. So here are 3 digits repeating, so we will write 3 times 9. So what this will be? This is our second solution. Now we will solve question number 3. 3.34 bar. We can write this 3 plus 0.34 bar. This portion we will use formula 3 plus 0.34. We can write here, we will use formula number 1. All digits are repeating after decimal, so write the digits and write as many as 9 as the digits are repeating. So 2 digits are repeating, so we will write 2 9 here, and on solving this we will get 331 by 20. So this will be the answer. Hope you all have understood all the examples properly and method and formula also. So see you in the next video. Till then, bye bye. Thanks for watching.